Up till now we have seen the details of scenario based model in which we have used use cases. Then we have seen the class models in which we have worked with the class diagrams, and then we have seen the flow models in DFD. Now we will look into the behavioral model. The behavioral model indicates that how software will respond to external events or stimulus. To create the model, you should perform the following steps. Evaluate all the use cases to fully understand the sequence of interaction. This is the most important in behavioral model, that you need to understand the sequence of interaction within the system. Identify events that drive the interaction sequence and understand how these events relate to specific objects. So you need to understand the interaction sequence as well as the events which drive that interaction sequence. Create a sequence for each use case. Build a state diagram for the system and review the behavioral model to verify accuracy and consistency. The use case represents a sequence of activities that involves actors and the system. An event occurs whenever the system and an actor exchange information. A use case is examined for points of information exchange. Let us understand, or let us consider the use case for a portion of safe home security function which we have already discussed or described previously. For example, the homeowner uses the keypad to key in a 4-digit password. The password is compared with the valid password stored in the system. If the password is incorrect, the control panel will beep once and reset itself for additional input. If the password is correct, the control panel awaits further action. So the object homeowner transmits an event to the object control panel. The event might be called password entered. The information transferred is the 4-digit that constitute the password, but this is not an essential part of the behavioral model. Once all events have been identified, they are allocated to the objects involved. Objects can be responsible for generating events. Homeowner generates the event password entered. Now we will convert this information into a state representation. So the state of a class takes on both passive and active characteristics. A passive state is simply the current status of all objects attributes. For example, the passive state of the class player is the current position and the orientation attributes of the player. The active state of an object indicates the current status of the object as it undergoes a continuing transformation or processing. The active state of an object indicates the current status of the object as it undergoes continuing transformation or processing. For example, class player active states are moving, at rest, injured, being cured, trapped, lost, and so forth. Let us discuss about the state diagrams for the analysis classes. One component of a behavioral model is a UML state diagram that represents active states. Active states we have already seen over here. Active states for each class and the events that cause changes between these active states. Let us consider an example of a safe home security function. So a state diagram for the control panel object is being shown over here. So this is an initial state. Let us see the state diagram for the control panel object. So state diagram, state is being represented by a rounded rectangle in a state diagram, and this rounded rectangle is being divided into 3 different compartments, in which on top the name of the state is being written, and in the middle compartment there will be entry and the exit points. That means like the condition to enter this particular state and condition to exit from this particular state. You can call it the precondition and the post condition is being written over here, and then what are the activity which is associated with it is being mentioned in the last compartment. So at very start this particular object has its initial state. Then when the key hit event is occurred, then it moves to the reading state, and from the reading state it starts reading the password which is being entered by the homeowner. When the password enter event occurs, this moves from reading state to the comparing state, and in comparing state, if the password is correct, that means if the password is correct, then it moves to the select state, and then particular camera will be activated. If the password is not correct or incorrect and the number of tries is less than the maximum number of tries, will again enter into the same state till the time maximum tries is not equal to number of tries. So once the number of tries are greater than the maximum tries, then it will be the state of that particular control panel will be locked state, and it will remain in there for some time. And once the time gets over, then it moves from this particular state to a reading state again. So this is how the state diagram basically look like. And in addition to specifying the event that causes the transition to occur, you can specify a guard and an action. A guard is a Boolean condition that must be satisfied in order for transition to occur. For example, the guard for the transition from reading to the comparing state can be determined by examining the use case. If the password input equal to 4 digits, then compare to stored password. The guard for a transition usually depends upon the value of one or more attributes, which is a passive state of that particular object. So an action occurs concurrently with the state transition or as a consequence of it, and generally involves one or more operations of the object. The second type of behavioral representation called the sequence diagram in UML, which indicates how events cause transitions from object to object. Once events have been identified by examining a use case, the modeler creates a sequence diagram, which is a representation of how events cause flow from one object to another as a function of time. So the sequence diagram is a shorthand version of the use case with function of time. It represents key classes and the events that cause behavior to flow from one class to another class. So each row represents an event, and the time measured shown vertically over here, and the narrow vertical rectangles represent the time spent in processing an activity. Here consider a partial sequence diagram of the safe home system, for which state diagram we have seen previously. So here you can see there are 4 classes which are participating in this particular sequence. So that at very start the system is in initial state, and when the system is ready, the homeowner creates an event of entering a password, which will be sent to the control panel class, and the control panel class will send the request lookup to the system for a particular password. The password is looked into a simple database, and the result is being sent back. If the password is correct, then again the control panel class will send password correct event to the system, and system will send the request or activation event to the sensor. Once the activation is successful, this is being sent back. This event is being sent back to the homeowner class. Activation is successful. So this is how basically this sequence diagram works. Up till now we have talked about the software requirement and then the analysis of those requirements. We have seen the various elements of the analytical model, like scenario based modeling, then class based modeling, behavioral modeling. So all these are being represented in the software requirement specification or requirement specification document. So SRS document is generated as output of the requirement analysis. A SRS is a document which contains the complete description of software without talking much about the implementation details. So it is a set of precisely stated properties and constraints which final product must satisfy. It clearly and accurately describes each of the essential requirements like functions, about performance, design constraints and the quality attributes of the system or software and its external interfaces. It also defines the scope and boundaries of the system or software. Each requirement must be described in such a way that it is feasible and objectively verifiable by a prescribed method. It should be a basis for contractual agreement between contractors or suppliers and customers. So its specifications are intended to a diverse audience like customers and users for validation, contract systems analysts for requirements, then developers, programmers to implement the system, then testers to check that the requirements have been made, and for project managers to measure and control the project. Various components of the SRS document are functional requirements, non-functional requirements, static requirements, execution constraints like response time, throughput time, etc. The standards to be followed, security requirements, company profile, company policies, then interface with the other external agents, that is persons, software or hardware. So the various goals of SRS, the first one is the feedback to the customer. So it is the customer's assurance that the development organization has understood or understands the issues or problems to be solved and the software behavior necessary to address those problems. So this is the feedback to the customer, that feedback will be satisfied once you show this particular SRS document, or if there is any ambiguity, he or she will get back to you. Next is a problem decomposition. So SRS helps to break down the problem into its component parts in an orderly fashion. So input to design specification, it is also an input to the design specification. SRS contains sufficient detail in the functional system requirements so that a design solution can be devised. It is a product validation check. SRS serves as the parent document for testing and validation strategies that will be applied to the requirements for verification. Now there are many characteristics of an SRS document. Basically the requirement should be correct and complete. It must be unambiguous, it must be verifiable, it must be consistent, it must be modifiable, and it should be prioritized, as well as the details in SRS must be represented at a right level of abstraction. Another characteristic that the requirements must be traceable, they must be design independent, and they should be testable and understandable by the customer. Now for this IEEE has come up with a standard 830 which is being introduced in 1998, or they have described the recommended practice for software requirements specification. Details of that particular document is been given. So the objective of this particular standard is to help the software customers to accurately describe what they wish to obtain, help software suppliers to understand exactly what the customer wants, and help participants to develop a template for the software requirement specification in their own organizations. Develop additional documents such as SRS quality checklist or an SRS writer's handbook. The benefits of this particular standard are, it establishes the basis for the agreement between the customers and the suppliers on what the software product is to do. It to reduce the development effort, to provide a basis for realistic estimates of cost and schedules, to provide a basis for validation and verification, and to facilitate transfer of the software product to new users or new machines. It also serves as a basis for enhancement requests. So there are various considerations in IEEE standard 830. You can just go through those. We will see the different sections which are of important to us. So IEEE 830 standard has a section 1 of SRS which talks about the purpose of this SRS and the intended audience, then in scope you have to identify the software product, then enumerate what the system will and will not do, and describe the user classes and benefits for each of those. Okay, then define the vocabulary of the SRS, then list all the reference documents including sources, then describe the contents of the rest of the SRS, describe how the SRS is organized. In section 2 you have to present the business case and operational concept of the system, describe how the proposed system fits into the business context, describe external interfaces like system, user, hardware, software, communication, etc. Then describe the constraints like memory, operational, and then site adaptation. Then various functions, product functions like summarization of the major functional capabilities, then include the use case diagram and supporting narrative, include the data flow diagram if appropriate, then describe and justify technical skills and capabilities of each user class, then describe other constraints that will limit developers' options, for example regulatory policies, target platform, database, network software and the protocols, development of the standards, development of standards requirements. Then in section 3 it specifies the software requirements in sufficient detail to enable designers to design a system to satisfy those requirements and testers to verify the requirements. Next is a detail all inputs and outputs, then like components with information details of all inputs and outputs like GUI screens, file formats, etc. It includes details of specification of each use case including collaboration and other diagrams useful for this purpose. It includes types of information used, data entities and their relationships. It should include basically standards, compliances, accounting and auditing procedures. The main body of requirements organized in a variety of possible ways like architectural specification, class diagrams, state and collaboration diagrams and activity diagrams in this particular object oriented model. Then in section 4 of SRS give the details of the requirements which are given to the third party for the development, and describe the details of the database which will be developed as a part of the project, and it also describes the details project plan, schedule and the budget estimates. This is how the SRS document has to be prepared and which will be useful for the design specification or design phase. Thank you. This is how we have completed unit number 2.